Get ready for a wild ride today, because we're going deep, and I mean deep, into the world of information digestion.
Information digestion.
You heard right. But we're not just talking about what happens after you eat a plate of nachos.
Okay, now you've got me curious.
We're going to uncover the surprising connections between how, cows digest their food and the future of artificial intelligence.
Whoa, that's quite a leap. You're really piquing my curiosity now.
Stick with me. It'll make sense, I promise. And to guide us through this unexpected journey, we're tapping into this really thought-provoking conversation between a couple of brilliant minds, Carlos and Casey.
Oh, I've heard of them. They blend a lot of real-world experience with some pretty big-picture thinking, right?
Exactly. And their chat starts with Casey trying to break down cow digestion on Twitter, of all places. And she has this funny realization like, wait a minute, cows eat a lot more than just grass.
It's amazing how easily we simplify things, even something as basic as what a cow eats. I think Casey's hands-on experience on the farm really gives her a unique perspective on that.
Totally. And that's where things get super interesting. She dives into the whole world of ruminants, like cows and deer.
Ruminants. Famous for their multiple stomachs. Imagine having a digestive system that lets you chew your food, swallow it, bring it back up, chew it again, and then swallow it for a second go-round.
Right. Talk about multitasking.
It's a truly ingenious adaptation. Those multiple stomach compartments are crucial for breaking down cellulose, that tough fiber found in plants. It's something that many other animals just can't digest.
It's like they've tapped into a secret food source that most animals don't even know about. But then Casey starts talking about horses, and it turns out they have a completely different strategy for digesting all those plants.
Yeah, horses are fascinating because instead of multiple stomachs, they rely on this specialized organ called the cecum, which is like a giant fermentation chamber in their gut.
It's like a whole other digestive pathway.
Precisely. And it highlights the amazing diversity in how different species have evolved to process information, in this case, the information contained in the food they eat.
It really makes you realize how much we take for granted when it comes to something as basic as digestion. And it makes you wonder, where do we as omnivores fit into all of this?
It's a great question, and it leads perfectly into Casey's next point. If our bodies were designed so perfectly, why do we have all these seemingly useless parts like the appendix and wisdom teeth?
Yeah, what's up with those evolutionary leftovers anyway?
Well, they're actually clues to our evolutionary past. Our ancestors, who likely ate a more plant-based diet, would have needed a larger cecum, which is what the appendix used to be, and those wisdom teeth. They were essential for grinding down all that tough plant matter.
So it's like our bodies are walking, talking museums of our evolutionary history.
Exactly. By looking back at our evolutionary past, we can begin to understand why our bodies are the way they are today.
It's like solving a puzzle, piecing together clues to reveal the bigger picture.
Precisely. And this idea of looking back in time to understand the present isn't just limited to biology. It's a concept that will be crucial as we delve deeper into the broader information ecosystem, from how DNA replicates itself to the explosion of knowledge in the digital age.
Okay, so we've gone from cow stomachs to evolution in just a few minutes.
And believe me, it's about to get even more mind-blowing.
It's like the whole world runs on this principle of, constant change and renewal. Pretty mind-blowing.
It really is. And it makes you wonder just how deeply embedded is this principle in the very fabric of, everything.
Okay, now you're going full-on cosmic on me. I like it.
Well, think about DNA for a second. We often hear it described as a blueprint, right?
Yeah, like the instructions for building an organism.
Exactly. But maybe that's an oversimplification. Because when you really get down to it, DNA is more like a self-replicating information storage system. It's information, but it's information that's constantly being copied and transmitted.
So more like a living, breathing code then, huh?
Exactly. And just like with any complex system, when you have information being copied and transmitted over and over again, you're bound to have variations creep in. Those are the mutations we're talking about.
And even though we usually think of mutations as something bad, they're really the engine of evolution, right?
Precisely. Mutations introduce variation, and variation is what allows for natural selection to do its work. It's why we have such incredible diversity of life on Earth, all thanks to these tiny little errors in DNA replication.
So from the tiniest microbe to the biggest whale, it all comes down to these little glitches in the code. Yeah. Wild.
Exactly. And the fascinating thing is this pattern, this cycle of information replication, variation, and selection isn't limited to biology. We see it playing out in the evolution of knowledge and technology as well. Think about how ideas spread and evolve over time.
Yeah, like One person comes up with an idea, they share it with others, and then those people build on it, tweak it, maybe combine it with other ideas.
Exactly. And sometimes those little tweaks and variations lead to major breakthroughs.
It's like a chain reaction of innovation.
It really is.
Yeah.
And just as we see specialized species evolving to fill specific ecological niches in nature, we also see increasing specialization in human society when it comes to knowledge and expertise.
Makes sense. The more we learn, the more we realize how much we don't know. So we need people who can really dive deep into specific areas.
Exactly. We have experts in everything from astrophysics to ancient history to, well, as we've been discussing, the digestive systems of cows.
Which, by the way, is way more interesting than I ever thought it would be. But it makes sense, right? We need people who can dedicate their lives to understanding these incredibly complex systems.
Absolutely. But this explosion of knowledge, as incredible as it is, also presents us with a new challenge: information overload. There's just so much out there now.
It's true. I feel like I'm constantly bombarded with information. From the moment I wake up to the moment I go to bed, it's overwhelming.
Exactly. And that's where Casey's experience on the farm, and particularly her insights into the importance of tacit knowledge, becomes so relevant to this whole discussion about AI.
Yeah, that whole tacit knowledge thing was eye-opening. It's that idea that there's a difference between knowing something in theory and actually understanding it through experience, right? Like, I can read all about how to bake a cake, but that doesn't mean I'll be able to just waltz into a kitchen and whip up a masterpiece on my first try.
Exactly. And that's precisely the challenge that AI researchers are grappling with. Because while AI is incredibly powerful when it comes to processing and analyzing vast amounts of data, it often struggles with the kind of nuanced, experience-based knowledge that humans acquire naturally through interaction with the real world.
It's like AI is trying to become a master chef by reading every cookbook ever written, but without ever actually tasting food or, trying to chop an onion.
That's a perfect analogy.
Yeah.
It highlights this fundamental gap between theoretical knowledge and practical know-how.
And how do you even begin to bridge that gap? Can you teach a machine intuition? Can you program it to learn from experience in the same way that humans do?
Those are the million-dollar questions in AI research right now. Some experts believe that the key lies in developing AI systems that are more embodied, more integrated into the physical world.
So instead of just feeding AI a bunch of data, we need to give it a body, senses, the ability to interact with the world in a more human-like way.
Exactly. It's about creating AI that can learn through experience, through trial and error, through interacting with its environment.
That makes a lot of sense. It's like instead of trying to build a brain in a vat, we need to build a whole organism that can learn and grow and adapt.
Precisely. And who knows, maybe by focusing on these seemingly simpler tasks, like teaching an AI to herd sheep or bake a loaf of bread, we might actually unlock breakthroughs that will help us tackle even more complex challenges in the future.
It's a good reminder that sometimes the most profound insights come from the most unexpected places. We started this deep dive talking about cow digestion, and somehow we've ended up on the frontiers of artificial intelligence, debating the very nature of knowledge and experience.
It's amazing, isn't it, how everything is interconnected. And it just goes to show that the more we learn, the more we realize how much we still don't know.
Which is both humbling and incredibly exciting. It's what keeps me coming back for more, always eager to explore these fascinating connections, these hidden patterns that reveal the interconnectedness of, well, everything. So until next time, keep those brains buzzing and we'll see you in the next deep dive.